All right, let's dive right into this explainer where we're going to tackle a massive environmental hurdle using a little DIY ingenuity and some absolutely satisfying physics. I just love it when we can look at a global challenge and say, you know what, I can actually do something about this right in my own garage. Today we're unpacking the realities of plastic waste, looking at the sheer mechanics of multiplying human strength, and seeing exactly how you can build a heavy-duty micropress out of standard lumber to completely crush your household's plastic footprint.
But first, to really understand why this matters, we have to look at the scale of the issue. 225 million. That massive number, that is the projected tons of global plastic waste we are expecting in 2025 alone. It's a staggering problem, and it's largely driven by our everyday reliance on single-use packaging. Believe it or not, an incredible 80% of the world's population already lives in countries that have entirely exceeded their waste management capacity. We are literally drowning in plastic bottles, and honestly, just getting them to the recycling centers is half the battle.
And this brings us to a huge logistical headache for waste collectors on the ground. See, the problem with collecting bottles isn't necessarily how heavy they are, it's the volume. When independent collectors or municipal trucks transport uncrushed bottles, they're essentially spending money, time, and fossil fuels to transport what we call recycling air. That hollow space inside a standard plastic water bottle makes it an absolute nightmare to move around efficiently.
So here's the crucial takeaway. A crushed bottle takes up just a fifth of the space of an uncrushed one. That is an 80% volume reduction. Picture a waste collector walking the streets, gathering plastics in a bag. An uncrushed load fills up that bag almost instantly. But if those bottles are squashed completely flat, that exact same bag can suddenly hold 5 times more material. It's a real game changer. This one simple change saves them countless trips and could literally double their income for the exact same amount of walking.
Okay, moving on to Section 1, Physics of the Compound Lever and how we go about multiplying force.
Now, you might be thinking, well, why not just step on them? But stomping on thousands of bottles by hand or foot is totally exhausting. Plus, you usually have to unscrew every single cap first just so the air can escape. Since doing that manually just isn't scalable, let's explore the mechanical hero of this explainer, the compound lever. You know that a standard lever amplifies your input force, right? But a compound lever is even better. Think of it like shifting gears twice on a bicycle. You are trading distance for raw, crushing power. It uses 2 levers in series. You calculate the advantage of the first lever, do the same for the second, and then you multiply those 2 advantages together. Basically, one lever feeds its output directly into the next.
And this is where the math gets really fun. While a standard single lever gives you a moderate boost limited by just one pivot point, a compound setup stacks those mechanical ratios. Let's say your first lever has an 8-to-1 advantage and your second has a 6-to-1 advantage. 8 times 6 gives you a 48-to-1 overall mechanical advantage. In theory, that turns a mere 100 pounds of human effort into a staggering 4,800 pounds of force. Even when you account for real-world friction and the wood flexing, you are easily generating over 4,000 pounds of crushing force with just a gentle, easy push.
Let's get our hands dirty in Section 2, Building Your DIY Crusher, A Maker's Journey. Armed with all that theoretical physics, it's time to bring it into the real world. How do we actually build this incredible micropress at home? Well, the design is beautifully accessible. It's meant to be built anywhere from a rural village to a modern suburban garage using completely standard 2x4 lumber, simple butt joints, and basic hardware like 3/8-inch bolts. You don't need to be some master metalworker for this. With just basic power or hand tools, you can create a heavy-duty piece of equipment capable of generating thousands of pounds of pressure.
But here is the absolute genius of this design, those puncturing spikes. Remember how I mentioned that stomping on bottles requires you to unscrew every single cap first? It's the worst. Well, when you place a sealed bottle into this press, these long spikes are positioned to just pierce right through the plastic as the lever comes down. They pop the pressurized bottle for you, completely removing the tedious step of unscrewing the caps. It is a massive time saver.
Now, safety first, applying 4,000 pounds of force to a smooth, curved plastic bottle can actually be pretty dangerous if it slips out. So, combined with those long puncturing spikes, the design cleverly uses smaller guiding nails to trap the neck and the base of the bottle. They act as a gripping mechanism to lock the plastic securely in place. Because, let's be honest, the very last thing you want is a slick plastic bottle shooting across your workshop like a rocket when you bear down on that handle.
Which brings us to Section 3. The optical sorting dilemma, or basically, when not to crush. So you've built your crusher, it works beautifully, and you're ready to flatten every piece of plastic in your neighborhood.
But hold on a second. Before you do, we need to impartially look at the realities of modern waste management facilities, because recycling isn't just a one-size-fits-all system globally. This actually brings us to a highly debated question in the recycling world right now. Does a crushed bottle actually help or hinder the recycling plant? Well, the answer depends entirely on the technology your local municipality uses to sort its waste.
As you can see, there are really strong arguments on both sides here. On the pro side, crushing bottles streamlines transportation, maximizes space at home, and works brilliantly with newer, highly automated plants that actually prefer uniform, pre-crushed plastics. However, on the con side, many older recycling centers still rely on automated optical scanners. These specific scanners actually need a bottle to retain its 3D shape so they can accurately identify the type of plastic. On top of that, extreme crushing can obscure or completely destroy the labels, removing the crucial identification markers that those sorting machines desperately rely on.
Let's wrap things up with Section 4, Sequestration and a Flatter Future.
Now, if you check with your local recycling center and find out they actually prefer 3D, uncrushed bottles for their optical sorters, do not throw away your DIY plans just yet. Your compound lever crusher still has an incredibly powerful environmental application for the plastics that simply cannot be recycled. Consider this staggering fact. Since 1950, 8,300 million metric tons of virgin plastics have been produced worldwide, but only a heartbreaking 9% of that has actually been recycled. The rest? It just sits in landfills, oceans, or gets incinerated. But communities around the world are fighting back. They're using devices exactly like this micropress to tightly compress unrecyclable plastics into dense, eco-bricks. These highly compacted bricks are then used as structural building materials for walls and community projects, effectively sequestering the plastic waste safely and keeping it out of our ecosystems. And for the PET plastics that do make it through the correct sorting system, whether they go in crushed or uncrushed, the energy savings are absolutely vital. Recycling existing PET plastic saves a massive 66% of the energy compared to refining brand new virgin plastic from petroleum. That reduces our reliance on fossil fuels, lowers carbon emissions, and pushes us ever closer toward a true circular economy where materials are actually kept in use.
So we've seen how simple physics, basic 2x4 lumber, and just a bit of maker ingenuity can multiply human effort to solve a massive logistical bottleneck, which leaves us with this final thought. Knowing that there's an incredible 4,000 pounds of mechanical advantage hiding in just a few pieces of scrap wood in your garage, what other household waste problems could you completely crush with a little DIY ingenuity?